Hello, my name is Martin Fahn with CalLogic Software, and in this video demonstration, we're going to be talking about Oracle Backup and Restore using CalLogic Software's ECX platform. So we're going to be performing this demonstration using an Oracle server residing on HPE Nimble storage, which we've recently introduced as a new storage provider supported in ECX version 2.11. So I have here a simple solutions architecture for our demo environment. We'll be using an Oracle database that resides on a Nimble storage LUN attached to a virtual Linux server running under VMware. And using direct API integration into the application server, the hypervisor, as well as the storage infrastructure, ECX can make calls to discover the storage LUNs on which Oracle resides. In this case, it's going to be a VMFS data store on Nimble storage and orchestrate the necessary operations to the storage appliance in order to create an application consistent copy of that database through a storage snapshot. Now, this zero footprint clone can be spun up for a variety of use cases very quickly by just simply mounting the snapshot directly. Um, and it can be used for test dev or a production mode point in time restore back to the original or alternate database server. In addition, ECX can perform operations to further mask the copy of the database for DevOps use cases so that a user can spin up that mask copy just as they would their production copy. So with that said, let's go ahead and jump right into the demonstration. So let's just really quickly go through our demonstration environment. I am running an ECX appliance, which I'm connected to the user interface via my web browser. I also am connected and running an Oracle database server on a Linux virtual machine running under VMware. This virtual machine has data stores connected to HP Nimble storage. You can see I have the user interface for my HP Nimble storage available to me within my internet browser tab as well. So now that I have my environment defined, I can go ahead and add these assets into my ECX configuration. And to do that, I'll click on the Configure tab, and you can see all the different provider types that are available and we support. So I'll right-click on Nimble Storage and select Register. Now here I would just need to provide a host name and an IP address. And then select a user credential that is capable of performing an inventory and discovery on that storage appliance. As you can see, I've already scanned in my Megalon appliance here. And as I've scanned it in, I'm now able to collect the metadata attributes of all the underlying volume structures, the snapshots, the hosts that this storage appliance can connect to. And this information is going to be pertinent when I actually go to spin up recovery and restore workflows from the appliance and connect them to my existing hypervisor and application server environments. Next, I'll go ahead and add my hypervisor by right-clicking on the VMware object and registering a new virtual center server. In this case, I've already had a virtual center server registered, and now this provides me with the ability of collecting that VM-specific metadata. And finally, I'll go ahead and register my Oracle database server by right-clicking on the Application Server tab and selecting Oracle as my server type. Again, I'll need to provide it with a host name and an IP address and specify whether or not it's a physical or a virtual machine. If it is a virtual machine, then go ahead and specify the virtual center server on which it lives. From here, I can also add a user identity or system credential, which I'll use to authenticate against the Oracle database server. Now, it's important that you use a identity that has both access to the underlying operating system as well as the database, because what will happen is we'll perform a code inject into the server that will allow us to run commands against the operating system as well as the database as we make our backup and make backup copies and run recovery of that database. So once I have my provider scanned in, let me go ahead and configure my SLA policies. Now my SLA policies are going to be my cookie cutter templates for how I want copies being created within the storage. So I'll create a new SLA policy on my Nimble storage array here. And in this case, if I want to perform a snapshot of some arbitrary source data, this could be an application or it can be a VM, I would just need to right click and select that snapshot operation, define how long I want to keep my snapshot. Let's say I'll keep this around for 15 days, and then I'll give my SLA a name. For example, I'll call it my silver SLA and click finish. So you can see here that I have 3 SLA policies now defined to my ECX enterprise. So now that we have our SLA policies defined, let's go to the Jobs tab to start configuring our backups. By clicking on Jobs and then right-clicking on our Oracle type, I can select Backup from the context menu and drill down into the Oracle instances, which I've done an inventory of. By selecting the database, I'm able to assign it to a previously configured SLA policy and just simply provide my backup job a name. By clicking on this Create Job button, I can create and execute the job. Additionally, I can also define a log backup option if I want to do a point-in-time restore, or configure data masking if I want to create a mass copy to use for DevOps workflows. This advanced button allows me to define additional options such as cataloging the backup job within my local RMAN repository, and that's going to allow me to do my database restore either through ECX or through RMAN, my preferred RMAN tools. I'm also able to define pre and post level job scripts as well if there are some additional tasks that I need to run before my snapshot operation. This is a job that I've already configured, and I can go and execute it by just right-clicking and selecting Start. And I can select the SLA policy that I want it to run with. And as it's starting, we should see the actions and operations that are getting performed as this backup job is executing. By clicking on the History tab, I'm able to see jobs that have already been completed. So just to go through real quickly what happens during a backup job is ECX is going to communicate with the hypervisor and with the application server and determine the LUNs on which the database files and the log files reside. And in this case, it's going to determine that these data files reside on VMFS data stores that are connected to Nimble storage and protect them using a storage snapshot on Nimble. It can do this by injecting an agent directly to the application server. So once that agent has been injected, we can start communicating with the database to perform any operations to put the database into a hot backup mode, such that the storage snapshot that we are taking is going to be application consistent. And as you can see, this happens within a matter of minutes. Now, jumping back to the backup job that I triggered previously, you can see these operations happen real time as we resolve the underlying storage device and take our snapshot. Jumping into the Nimble Storage UI, I should be able to see those recovery point snapshots for that storage volume appear. And you can see here that I have new snapshots appearing that represent the point in time with which I took a storage snapshot from the ECX backup job. Now that I have a backup, I can go and recover from the snapshot by just simply right-clicking on Oracle and defining a restore job. So I'll click on restore. There are different options I can use for restore, such as restoring the entire database or restoring a mass copy of the database. So I'll just choose the instant database restore, and from here, drill down into my database instance and select the database that I want to recover. My catalog is going to be keeping track of all my copies, so it knows I have copies located at specific sites, and I can drill down into those sites and select the copies with which I want to restore from. Now, each of these versions I see here listed in my catalog should correspond to recovery points or snapshots also on my HP Nimble storage. The final screen here is the destination where I want to recover the snapshot to, and I can select the original database server. In this case, I only have one database server scanned into my enterprise, and also provide it with a new database name to recover it back to. So I'll just call this testdb1. Provide my job with a name, and click the Restore Create Job button at the bottom right-hand corner of the screen there. Now this is a restore job that I've created previously as well, so I'll go ahead and start this restore operation so that you can see exactly what happens as we move to recover this server. So ECX knows the snapshot that it's trying to recover is of a database server, and it knows that it's trying to attach that database to a virtual machine. So it's going to communicate with the hypervisor layer, the host within the hypervisor layer, and mount the snapshots as temporary data stores to that ESX host. Once it's mounted the snapshots, it can add them as temporary data stores to our ESX host and continue to perform and attach that database to the database server. So if I jump back to my PuTTY session here, let me just go ahead and issue a query against my running database processes, and I see my default DB18C1 database instance running. I'm going to go ahead and let this continue to run, and we'll come back once we have our restore job completed. So here we are coming back from the break, and as you can see, my restore job is completed. And what happened in the background here was we've taken the snapshot, we've presented up as a new LUN from our Nimble storage array, mounted them as VMFS data stores, and attached them to the database server as virtual disks. And from there, we were able to restore and recover the databases on our Oracle application server. So if I were to go back into my PuTTY session here, I can issue that same query against my Oracle Process Monitor, and now I see a secondary instance called TestDB1 that is available for me to use and query against and perform testing on. Now this is just a temporary database that gets presented from my HP storage as well as to my ESX host, and I have the option to promote it to production or cancel that restore. So if I want to make it permanent, I can just go into the actions menu and select make permanent. In this case, I'm just going to go ahead and cancel the restore, which will then tear down that database, remove the temporary storage LUN from my HP Nimble storage array, and also dissolve the database from the database application server. So I hope you found that video informative. If you do have any questions, please feel free to contact us or visit our website at www.catalogicsoftware.com. Thank you for your time.